Hi, I'm Vince. I used to work on some console games. Then I worked on a game engine called Gamebryo. Did that for about 5 years. And now I work at Google on the web browser Chrome. I'm going to talk to you for about an hour on the bleeding edge of open web tech. So let's define open web technologies. The open tech is basically APIs that are available for you as a developer that is implemented by one or more browser vendors, or at least could be implemented by another browser vendor if only one browser vendor is implementing it at this time. Often, these technologies go through a standardization process. For web technologies, that's frequently the W3C. That offers benefits for gathering feedback in a central location and going through a very formal process of hardening and stabilizing of specifications. Sometimes this technology is also open source. It's available for you to look at the source code and include in your own projects as well. There are several benefits of using open web technology. Basically, they come down to being a free economy or a free market. Because multiple browser vendors are implementing a technology, there's motivation to compete for implementation quality and speed to implement APIs. That benefits you, the developer, who wants the highest quality APIs possible. In the open environment, it's also easier for you as a developer to influence that technology and the progress that it makes. And the individual browsers that are making those technologies are more keen to pay attention to actual application needs, because if they don't pay attention, another browser vendor will, and they'll lose market share. Open tech also helps technologies live longer. You have more trust in the longevity of a technology when there are multiple implementations, when you have the ability to even implement it yourself if needed. So in this presentation, I'm going to be focusing on the bleeding edge of open web tech, specifically with a lens for games. Now, a year ago at Game Developers Conference, I gave a presentation doing a survey of all the technology that I thought was relevant for games. And I went through all the basics and went through a lot of examples. A lot has happened in the last year, and in this presentation, I'm going to try to focus on what's happened recently, in about the last 6 months, and also focus on the current discussions and possible futures for these technologies. To do that, I'm going to have to jump through a lot of different technologies. So I've got an overview here mentioning graphics, networking, audio, etc. We're just going to bounce around through all these technologies, and at times it can be a little bit janky, but bear with me. We're going to just cover all the news that I could find that I thought was interesting for game developers. At the end, I'm going to talk a little bit about apps, stores, and browsers. The takeaways I hope you're going to have are new awareness of technologies and the future direction of those technologies, an idea of the current state of the platform, and I'm going to do that through some demos of actual commercial games running on technologies today. With this information, you should be able to go back, work on current games that can deploy today, but some of the technologies I talk about aren't going to be ready for shipping a game stable today, but they're definitely ready for you to do R&D work on and plan for the future, and also to influence the direction of the open web platform. So with all that said, let's get started with a demo. This is Skid Racer, and let me bring it up. All right, so this demo, or this game actually, is currently shipping. It's available in the Chrome Web Store. It's been implemented in JavaScript. It uses WebGL, the Web Audio API, and let me just try racing along a little bit. So a caveat of all of my demos, it's a little bit tricky to demo on the spot, and I'm not always the best player. But I hope you get a sense of, hey, wow, a 3D game looking like this, running in JavaScript, that's awesome. If you had shown me this 3 years ago, it really would have blown my mind. It's awesome that web browsers are becoming a platform so capable for this level of quality of games today. And I'm really excited about the future of getting higher and higher quality games available in the web browser. So let's get into the meat of the presentation. What I'm going to talk about first is performance. For myself, at least, I always used to think about the web platform as a fairly low-performant platform. JavaScript was pretty slow. I didn't think a lot of it. I was a console game developer. It was all about optimized C and C++, doing assembly coding, doing shaders and things like that. Well, there's a lot of movement across all vendors to improve the quality of performance, and let's hit some of those topics. One important concept is going multi-threaded. Web workers provides the ability for JavaScript to run in parallel. On a traditional web page, there's just one thread of JavaScript that is modifying the contents of the page for display, and it competes with several other things the browser itself implements to display that page. Web workers allows you to have JavaScript code that runs in parallel on another thread. Some recent news there is that Internet Explorer is adding them into IE10, so that's great because that'll bring them to all the major browsers on the desktop. In Chrome, there's been recent improvements as well. For example, they've been moved into the same process as the main thread, lowering the memory footprint. Chrome uses multi-processes for part of its sandboxing technology, which is why they were in one per process previously. In web workers, there is a method you can call called postMessage, and this is the synchronization primitive of web workers. There is no mutex or other synchronization primitive available. There's really just message passing. Previously, passing messages always meant copying your data. Copying the data is fine when it's small, but when you're dealing with a game, you might be trying to, for example, take your physics simulation and run it in the background thread, and then push updates to the main thread for display through, for example, WebGL. You might be updating quite a bit of data. It could even be a couple megabytes. So making a copy of all that is a poor choice. postMessage now includes the ability to transfer ownership. So on the background thread, for example, you can update and prepare your world state, and that could be quite large. You would call postMessage, and on that object, you would lose visibility on the background thread, and it would gain visibility on the main thread. It would just transfer the ownership. Eric Beidelman from Chrome DevRel did a quick check of, for example, transferring 32 megabytes between threads, and on one machine, he saw an improvement of 300 milliseconds down to 7 milliseconds. It's almost 2 orders of magnitude performance improvement for transferring large blocks of data. So that's pretty cool. Along the lines of performance, another thing game developers have been asking for is vector support and matrix support as first-class citizens of the language. The good news is this is in discussion now on the public effects working group list. Matrix 4x4 looks like it's going to be the first class to be implemented into JavaScript, and it's just sort of a beginning step for linear algebra types being available in JavaScript. But it's a great start because as we move forward, I expect we'll be able to see more and more types and classes available, which can lead to better optimizations in the JavaScript virtual machines and easier utility for game developers. JavaScript in general is always improving. Mozilla has a great phrase, "Are we fast yet?" where they've been tracking the speed of their performance for JavaScript, and they've been making improvements year over year. Chrome, when it launched, was notable for its inclusion of the V8 engine, which has excellent performance, and it's been improving well over time also. Some recent news is that incremental garbage collection has been introduced in both Chrome and Firefox. That reduces the occasional pauses that garbage collection would introduce into apps. In games, that's a really poor scenario because it causes you to drop frames or have a stuttery frame rate. Now that it's incremental, that problem has largely been diminished, and there's more of just the simple constant tax of garbage collection instead of postponing it and then having a stuttering frame rate for your users. Type inference is also now available. Type inference allows for more aggressive optimizations. JavaScript is when you pass in data to functions, it could be of any type. It could be a string, it could be a number, and that's a problem when you're trying to optimize that code. Both Firefox and Chrome are doing optimizations based on type inference, and they are realizing, hey, this inner loop is really only running off of numbers, and specific machine code can be highly optimized for that. In Chrome, there's a technology called Crankshaft that does this with stochastic profiling in real time of where the hotspots are in your code and aggressively optimizing those. A recent Firefox report indicated that they had a 2x improvement in their Box 2D performance over the last year, which is pretty cool. It's now about 6 times slower than native hand-optimized C and C++ code. So JavaScript is definitely getting faster. Another component to talk about in performance is the use of typed arrays and how they're spreading. These were initially introduced in WebGL, where they've been used for vertex buffers, textures, etc. You specifically were able to specify the format of data that you're replacing into these arrays, which helps with your code being optimal in accessing that data. They're now available for transferring objects between threads. As I mentioned earlier in web workers, typed array is one of the object types that can be transferred and have the ownership transferred. They're also used in networking with WebSockets. When you're sending binary data, you can do it through a typed array. XML HTTP request, or XHR, is also supporting loading data directly into a typed array. So when you fetch your assets from a web server, you often are doing so with XHR, and previously you had to reprocess that data in order to prepare it for use with WebGL. Now you're able to, if you choose, optimize the client-side processing by loading it directly into a typed array. And the last thing I want to mention in performance is Intel's Rivertrail. So this is a pretty cool project that they announced. It is open source and available on GitHub, and they have a demo that you can try out in Firefox. Their goal here is to enable you to take advantage of more and more CPU power. They want you to be able to take your embarrassingly parallel applications and implement them in JavaScript easily. So they have a concept called parallel arrays, and what you can do is implement a function in JavaScript that's a kernel operation. And you implement that function in the context of just a single element in an array, or for example, a pair, say the ith offset of both array A and B. That kernel then composes a new result based on those inputs, and it can do so in parallel. The framework itself can spread it out based on the number of processors on the machine to take advantage of all the hardware. It's pretty cool. It's probably still a ways off from actually being considered into a stable shipping browser, but it's nice to see the research work being done to bring massively parallel operations to JavaScript. So that wraps up performance. Let's move on to graphics. In graphics, we're going to start from the beginning. How do you get your content on screen? Traditionally, you did this with a timer. You would update your state of your web page and hope it's displayed to the user. If you want an animation, you would set a timer and try to update 10 times a second, or maybe 100 times a second. The problem is you might be running ahead of what the browser can actually display to the user. You have no idea. You're out of control in this situation. Request Animation Frame understands that the browser is compositing all the content of a web page and the browser UI and displaying it to the user. It knows what rate things can be displayed. By using this function, you take your JavaScript code and provide a callback that the browser will call as soon as it can to display the next frame. You'll be called once every time the browser is going to display content on the page. So it gives you the ability to render at 60 Hertz without doing too much or too little work. It has some other benefits as well. If the user tabs away, for example, to check their email or anything else, Request Animation Frame will stop calling your draw calls on tabs that are not visible. So that helps you be a better citizen by not consuming computing resources that are going to go to waste. It does the same thing if you have a particular element on a web page and that element is scrolled out of view. So if you have a very long page that has a lot of dynamic content, that content is only being rendered and updated when it's going to be visible on page. So now that we've got our cycle of draws in place, let's try to show them on screen and make them as pretty as possible. I've got another demo of Fullscreen that I think shows this off well. Previously, browsers allowed you to go into presentation mode, and you could make the browser full screen and take the whole web page contents up. But in this case, we've got a game that's basically in a little box. And what we want instead is on the web page, we want the ability to click a button and bring a portion of that page full screen. We don't have to tell the user how to interact with the browser's specific user interface for going full screen. we can just put the controls directly into a web page or into a game and allow transition into full screen. So very useful, especially for games where we want to really take over the entire monitor display. And now I'm going to talk about WebGL, which is really the meat of graphics. There's quite a bit of news here. So some recent things. First of all, if you're not familiar with WebGL, it's OpenGL ES brought to JavaScript bindings. OpenGL is a long-term graphics API available on the desktop. It was fairly large, and when mobile platforms started to support 3D, they wanted to minimize it to just the recent high-quality feature set without any redundancy, and that became OpenGL ES. WebGL exposes that to JavaScript. So some recent news in WebGL is that texture compression is becoming available through an extension, and that provides S3TC, or more commonly known as DXT, compression formats. So that's great to know. In Chrome, we've recently made it so that errors are automatically reported to the console without performing any special operation for any of the error checking that we have to do as just part of normal security checking, which is a fair amount of error checking in OpenGL. If you want absolutely all error checking to be done, you can use a command line switch, enable GPU debugging, which will call GL get error after every call that you make. And that will help you find any errors rapidly. Firefox, I believe, has always had an option, although you have to enable it, to display errors in their console. Some of the upcoming features in WebGL are the support of 32-bit index buffers. Currently, they're only supporting 16-bit. Also, an extension to offer instanced drawing. And finally, shared resources across canvases. So in WebGL, a canvas is the area of a web page that you can send your 3D content to. For games, you're probably going to have just one canvas, but it's possible that you might want to have multiple viewports interspersed with other web page content. If you do that, today, you can't share vertex or texture data between those canvases, and so work is underway to enable you to do that. That's somewhat interesting, but where it becomes more interesting is in the somewhat longer-term future of WebGL. At that time, we're hoping to share resources across web workers as well. So I mentioned earlier, for example, performing a physics update on a background web worker. When you do that, you will have to transfer that data to the main thread for submission to WebGL. But it would be great if directly from the background thread, you could update resources, send them to the GPU, and have them ready for the main thread without blocking that main thread. Other things coming a little bit further down the road are anisotropic filtering, and also depth textures, which has a little bit more of a dicey implementation questions, especially around supporting DX9, but is solvable. So because I'm talking about graphics, it's great to have demos. Many of the demos that are available on the web now are tech demos. There's a few commercial games like the one I showed earlier. This is just a ship viewer for Eve, which I think is great because it ties in WebGL as utilized in an auxiliary means for a large and well-known commercial game. So they just have a ship viewer, but it's pretty cool. You can see these high-quality assets, fly in, zoom around a little bit, and it's nice to see other games that have been long-standing for some time starting to use WebGL in situations such as this. One more. Cool. All right. So now we're going to switch gears, talk a little bit about networking. On the internet, networking has always been around, right? But it's always been in a client-server model, and it's been more about fetching resources. So typically, a web browser says, hey server, can you give me that web page? Can you give me that image or that audio file? For games, we want something much more rapid to enable gameplay. So WebSockets is a technology that supports that. It's client-server still, but it's bidirectional and low latency. Previously, to support bidirectional or to allow the server to push data to a client, the client had to open up a connection to the server and leave it hanging. It was kind of awkward, and it definitely didn't solve the low latency problem. WebSockets does, and it's available to work with in Chrome. It's also being unprefixed in Firefox 11, so it'll be available for production games there. and Internet Explorer 10 is bringing support as well. Initially, it supported just text transfers, but binary data is also on board, and so you can optimize your bandwidth usage considerably now. So if we're talking about networking, WebSockets is only going to solve the client-server problem. You also want to solve peer-to-peer problems. So to do that, I need to talk about WebRTC. But this is a large project, so let me start at the beginning. The goal of WebRTC is to bring video conferencing capabilities and technologies natively into the browser with APIs so that developers can use them in any way they see fit. So this includes codecs for audio and video, real-time encoding and decoding, echo cancellation, noise reduction for both the audio and video, automatic gain control for the audio, network jitter management, again for both audio and video. And also, because they're peer-to-peer connections, it includes a solution for NAT and firewall traversal technology. So that's a great start, and basically you'll be able to get things like Google Chat working on your own web page or game with APIs that are going to be built directly into the browser. However, that's just video chat, and while a lot of games are going to use video or even just the audio portion of that, it's still not what you really want. What you really want is the Data API. So this is currently under discussion. The Data API's goal is to allow you to have multiple channels of application-specific data piggybacking on one of these peer-to-peer connections. It can be reliable or unreliable, and it will allow you to send strings, binary blobs, array buffers, etc. It'll also allow your application to check to see if that data is being buffered so you can adjust your send rate based on the bandwidth available. So that's basically the holy grail for games and peer-to-peer. It's the closest thing we're likely to get to UDP through web standards. It's still in discussion right now, but the rest of WebRTC has gotten into technology preview in at least Chrome and Opera at this point. So one portion of WebRTC is just the audio and video. And there's a method called getUserMedia, which allows you to gain access to that, even if you're not going to send it over the network. So I've got a demo I want to show you for that as well. Let me launch that up. So basically, you can say, hey, is there a camera attached to this computer? Let's load it up. And here, I've got a WebGL application that has got me. Hi, me. How's it going? And I can watch TV on TV, which is kind of cool. This came from learning 3JS. So it's accessing my webcam with no plugins, just directly through the getUserMedia API. So very cool and definitely appropriate for certain types of games. On Chrome right now, it's behind a media stream flag. All right, so we've already started getting off the topic of networking, talking about video and audio. So let's just switch directly into audio. Audio has been available in web browsers for some time. The early history is unpleasant. In HTML5, the audio tag arrived. The goal there was to make including audio on a web page as simple as including an image. You just put a tag on the web page. Game developers noticed this tag for audio and said, hey, that's great, let's try using it. The problem was it was initially designed and implemented in the context of including a song or maybe a streaming presentation onto a web page. Controls are optional and can be displayed to the user so they can seek around and pause the audio stream. You can create multiple hidden audio tags to have a sound bank in the background and use that for sound effects in games, but this has been fraught with peril. A couple of months ago, there was a conference called New Game. They had several presentations, and I think every presentation had complaints about the state of audio today in the audio tag. There are definitely some problems there. The good news is there's been significant progress in all browsers, improving the performance and the quality of that implementation, but in the long run, it's still going to be an overly limited mechanism to implement audio in your games. So there are some other APIs that are worth talking about. A while ago, Mozilla presented the Audio Data API, which took the audio tag and it built on it a little bit by offering a JavaScript source for that streaming data. Basically, every time the audio needed additional samples, they could be produced in JavaScript. This project has been sunset by Mozilla in favor of another API, which I'll describe a little bit later, but it also it suffers from some problems in that requiring JavaScript implementation of all your audio processing is pretty heavy-handed when much of it could be heavily optimized directly in the browser. That's the route of this API, the Web Audio API. The Web Audio API is recently available in Chrome. It started shipping last fall and can be used today in stable versions of the browser and has ongoing work. In November, Intel jumped on board in WebKit and started doing some additional optimization. And recently, in January, we added support for sourcing audio channels directly from audio tags. The audio tag has a couple of good properties, including the streaming capability, so you don't have to entirely preload your audio data. So that's recently available in the Web Audio API. And there's been a lot of background or back-end work and optimization being done there. Angry Birds, which was a game that was ported to HTML5 tech and runs on Chrome last year, has recently been transitioned over to Web Audio API, so there's that and a few other examples of production games using this API. The API was initially designed using Fmod and WWise and Miles, I believe, from the game industry as inspiration for a lot of the use cases and needs that developers would have. So it's a very suitable API for games. Moving forward, there are several things yet to be done with this API. It could be tied in more tightly with WebRTC. For example, getting access to your audio stream coming in from your webcam, or let's say you want to plug your guitar directly into your computer and then process that as well. There's also a question of multi-channel sound. Now that's multifaceted. Today, you can load surround sound through an audio tag, and you can render that out to your speakers, and it works all right. But what you can't do is separate those channels and manipulate them independently. Being able to support that would be great. So that's sort of decoding multi-channel audio, and then also re-encoding that when outputting to speaker configurations. That would provide the ability to also do the 3D spatialization that the Web Audio API offers, but on multi-channel audio as well. There's also a scenario for multi-bus audio. So consider, for example, a DJ. They're playing some music, and that's going out to the house speakers. But they also want to preview what they want to queue up next. So they want both of those to be, say, in stereo. And so it's multi-channel, but it's not all the same music. It's not all synchronized together. That would be great to support through this API as well and is being discussed. There's another question about device discoverability. So what kinds of speakers are on this computer and what kinds of audio inputs are available. Providing that through the API somehow. That, again, is still in early discussion and is also related to the Device APIs working group. And finally, allowing parallel processing of audio. Right now, if you perform JavaScript processing using the Web Audio API, you have to do it on the main thread. But it would be great to offer something like a on-audio process call that could be made on a worker thread instead of on the main thread. So I've got some demos that are worth showing off here. Let's launch some of those. There's quite a bit to cover, so the first thing I'm going to do is something simple. Let's just show rendering out an FFT of an audio stream, and also playing with convolution, providing pre-recorded reverb plate. Bring it back to dry, bring it up to the full reverb. All right, we can also do multi-track. So here's a demo that has several tracks, all being independently visualized and controlled with sliders. We can bring levels down and up. And we can solo out channels. Cool. All right, and sample accurate scheduling, very critical for games and one of the largest deficiencies of the audio tag. Here's a simple tech demo showing very tight synchronization. And And just along the lines of synchronization and hopping around, here we've got a song broken up into fundamental components, just little short snippets. And as I mouse over, I can cue them up in any order that I feel like doing it. All right, and let's switch over to synthesizing some sound in JavaScript. Byte beats are a cool little toy, especially if you're into demo scene type things. You take an equation, you get an input for time, and you just output a number, and we interpret that directly for audio. Very cool, and just an example of what you can do in JavaScript. This demo can be live edited. All right, so let's move on. So another thing you need in audio is, so another API that has been proposed, and this is what Mozilla is currently stating as their hope for future implementation, is the Media Stream Processing API. This API shares a lot in common with the previous API. They're both graph-based APIs where you configure from JavaScript a series of nodes for leveling, reverb, convolution, etc. They have a very syntactically different approach here, but the underlying concept is quite the same. It's at early days for this API. It'll be kind of interesting to see how it moves forward. And for more details, you really have to read through the spec. And if you're an audiophile and a developer, I definitely encourage you to get into the audio working group and express some opinions about the pros and cons of those APIs so that we can start to hone things down into a unified API. One last thing in audio is the MediaController, a fairly simplistic API that allows you to tie multiple sources together so that they're synchronized. Consider having a video and 2 audio tracks. They could be streaming live, or perhaps one audio track is already downloaded by you, but the other sources are streaming live. They could be streaming from multiple sources. Say, you want to make sure that they all stay in sync and never get out of sync. The MediaController allows you to tie them together. In the event that one stalls, it'll hold all of them together and things like that. So small but very useful API. All right, let's move on to controls. The web has a fairly straightforward keyboard and mouse control scheme, but it can handle some improvements. Personally, I'm working on the pointer lock API. This is basically mouse lock, and again, probably easiest to show off with a demo. You have a mouse cursor on your computer, and you move it around with your mouse, but that's kind of frustrating for games, especially in first person. So I move into full screen here, and I try moving around, but I have to keep dragging with the mouse, and I can hit, for example, the edge of the screen, or if I wasn't full screen, I'd fall off an element. I can disable the mouse cursor. So here, my JavaScript requested it, I clicked on OK at the top of the screen, and now there's no more mouse cursor. I can move around freely the same way you would in any first-person game. I can exit and re-enter that mode, and because I've already given it permission, the permission is remembered, and it's just the kind of experience that you want for games. So fairly simplistic. It's great to have it moving forward. I've got an implementation in Chrome that's available behind a flag for JavaScript. It's available for shipping native client games right now, and on the Firefox browser, there is work underway as well. It's available in special builds that they have also. So, good stuff. Hey, now that we're talking about games and controlling them, let's talk about gamepads. So, right here I've got an Xbox 360 controller. Some games, I prefer to play with a gamepad. So in this case, that wasn't previously available on the internet, but API is underway in Chrome and Firefox again to offer this support. So here I can push buttons on my gamepad controller and read them on a web app. Very cool, very useful. Some games are just going to be best with gamepads. Great. All right, so we're going to cover a few remaining miscellaneous items. Page visibility. I mentioned request animation frame and how you can be a good citizen by using that and allowing the browser to not call your code when you're not visible. That's not necessarily the only hook that you're going to have for doing processing work. You might be doing other processing on a timer or on a background thread, for example. The page visibility API gives you a direct notification that you can check for is this tab visible or not. Also, IndexDB. This is one of many local storage options in HTML5. For game developers, the file system API is going to be very relevant because files and directories are a very good way to manage assets. You can cache them locally, etc. That is great. IndexDB has some recent news, though. IndexDB is a little bit more of a database approach. It does have efficient searching, but it's not really structured in a file system. It does have fairly wide support, though. Internet Explorer 10 is offering support. Mozilla has support. They're adding blobs and files into IndexDB as well. Basically, it's on all the major browsers, with the one exception of Safari so far. It is even as well included on Chrome for Android, so that's good to have it available, and it is a very good option for the broadest support of sophisticated local storage for your game. All right, so transitioning out of some of the raw platform capabilities, I'm going to talk about some language options. Everything I've shown you so far has all been done with just straight up JavaScript implemented directly, but that's not the only options available. There are two projects, Emscripten and Mandreel, that are interesting in that they use LLVM. Now, LLVM, if you're not aware of it, is basically a low-level virtual machine, which is a misnomer. It's more of a cross-compiler or compiler middle end that can do optimization work. It can have multiple front ends, for example, GCC-based, so you can read in source code from C, C++, C#, and others, and bring it into this compiler. It can do optimization work, and it can have different backends as well. So Emscripten and Mandreel output to JavaScript as a backend. The JavaScript they generate isn't really human readable. It's essentially a bytecode format. That is interesting because it provides access to large code bases that are implemented in these other languages and bring them over to JavaScript. It's also interesting because those other languages have perhaps more strongly typed scenarios or don't have concepts of garbage collection. When they're implemented through this technology, on the back end, you end up treating large arrays as memory directly, and it can significantly reduce pressure on the garbage collection system inside JavaScript virtual machines. So Emscripten is an open source project, but I mentioned Mandreel because although it is a proprietary solution, it has some really interesting demos and games that have been ported onto it. So I want to show you this one, GT Racing Motor Academy. This was initially made available on iOS, and here is running in JavaScript with WebGL, Web Audio API. It's using the HTML5 storage options to cache assets, so if users return to the application later, they don't have to have significant load times. And it's just great to see the possibility of bringing such a large library of high-quality game content over to the web platform rapidly. So very cool. Another thing that both Emscripten and Mandreel do is offer basically library shims for software packages that original applications might have been using. For example, if you were using OpenGL ES 1.1 or 2.0 in your C++ code, when you convert them using these tools, they're converted for you automatically onto WebGL. All right, so that gets you from a lot of languages. There's another project worth pointing out called PlayN. PlayN is built on top of the Google Web Toolkit, and it allows you to take large Java applications and port them onto JavaScript as well. PlayN can support multiple targets, but JavaScript is the one of interest to me right now. Angry Birds is a good example of a commercial game that has used this technology. PlayN includes a little bit more than just language conversion. It does also have a framework that is utilized and then ported onto those multiple targets. So that being said, those are the options to convert or transcode your games onto JavaScript, but there's another option available as well. There's an open source project called Native Client. It is done by Google, And its goal is to allow you to take native applications and deploy them safely and securely on the web. Today, when you browse around the internet, you download JavaScript code all the time, and it's running in your browser, and you trust that it can't harm you. If you just downloaded executable files onto your computer, you wouldn't have the same level of reassurance. Native Client is a sandboxing technology that lets you get very close to that, though. It downloads code in machine format and does a very efficient static analysis to ensure that it will conform to the sandboxing rules that Native Client enforces. This means that code can be very high performance because it can be optimized, for example, from C++ and run in machine code without going through a virtual machine. So it's been shipping in Chrome since last fall, and it supports C, C++, C#, and others. It has a lot of games that have already shipped or are shipping soon on it. Some examples include Bastion, Mini Ninjas, Moonbreakers, some MMOs, Pocket Legends and Star Legends, Cordy, Muffin Knight, AirMech, etc. Some cool things coming in the future, Dark Legends, From Dust, and more. So I'm going to show you a demo of AirMech, which is kind of cool. All right, so this is basically an RTS style game. I can move units around, drop them off, get into dogfights, and because it's AirMech, of course, I'm also a mech. I can land and engage in combat. Cool. So Native Client, I think, is awesome. It brings really high quality games from these other languages at a very high performance onto the web platform. And it really opens up your options for what technologies you're going to use. As a game developer from the middleware industry, I was aware of a large amount of awesome options that can get developers producing the high quality games they want faster. Well, a lot of high quality middleware solutions have signed up for Native Client as well. They include Havok, Unity, Fmod, Wwise, SDL, Bullet Physics, BlitzTech, and Ogre, among others. So very cool stuff. All right, so just a few more things to talk about that are a little bit more in the future. Device discovery. I mentioned in audio, it'd be great to know, hey, what's connected to this computer? But from your controls, it would be too. Does this computer have a touchpad or a mouse? It's going to change how I want you to interact with it. Maybe it's a touch-based device. You know, what's the general performance characteristic of this machine? Am I on a phone or a tablet, a netbook, a high-end laptop, a workstation, or an awesome gaming rig? You know, I will send different assets down from the server based on the general performance of this platform. These bring challenges, though, for privacy of users. If you're not familiar with the fingerprinting concept, it's something we have to be concerned about. When a user browses the internet with a web browser, they expect a certain level of being anonymous. And the more information a web page can just pull about a user, the more of a fingerprint they can build up and uniquely identify that user, which is not desired. Another thing we could use on the platform is better time handling. So examples include, right now you can call new date, and you can get the time, but only up to 1 millisecond. So 1 millisecond is pretty granular when you're dealing with a game trying to run at about 16 milliseconds per frame. Chrome has a command line flag, enable benchmarking, that allows you to get microseconds and could be great for, especially in the profiling nature of your game. The other issue with time that we have is when timestamps are applied and the latency related to that. So for example, in Chrome, when a button press on a gamepad or when the mouse is moved, those events are eventually dispatched to you in WebKit, and the timestamp, or via WebKit code, and the timestamp given to those events is the timestamp that we got to dispatching them in WebKit, but not necessarily when the operating system actually informed us at the browser level. So there can be latency there that is made even worse, for example, if we're waiting with request animation frame before we're delivering certain events. So it would be good to mark the actual time on events with the closest value we can get to the time that they actually happened. And I work on pointer lock. There's some other kinds of lock that would be great. For example, keyboard lock is a good one. In a first-person shooter, if I want to crouch and walk forward, I'm probably going to press Control-W instinctively. The bad news is, in a lot of browsers, that's going to close the current tab, and that's not what I wanted to have happen. Another thing we could do is orientation lock. On a mobile phone, if I want a game that is using accelerometers, I want to be moving it left and right, I don't want it to reflow between portrait mode and landscape mode just because I'm changing the orientation. I want to lock that down and not have it change. All right, so let's wrap up a little bit with a quick discussion about apps and stores. Chrome has been offering an application store for a little while now, inspired by the success of a lot of the mobile platforms where users are getting very familiar with the concept of an app, giving the app a certain amount of permission, and using that for discovery and replayability. This is coming to other browsers as well. Windows 8 has announced that they're going to have a store, and it's going to host HTML content. So that's pretty cool. Mozilla also has announced an app marketplace, and they have another concept they've announced called WebRT. The WebRT is for web runtime, and the goal there is to allow applications to get as close as possible to having a native-like feel. They should have nice icons that look just like any other icon, and they should have more availability to APIs that are native on the system that they're running on. All right, we're going to transition over to just a quick summary of the state of browsers. Desktop share right now is really dominated by the top three of Internet Explorer, Chrome, and Firefox. And on the mobile space, still really just three strong leaders, Opera, Android, and Safari. A little bit of mobile news. Firefox has a beta version available, and Chrome recently announced a beta version available on Android as well. So very cool, worth checking those out and seeing how they perform. They bring a lot of HTML5 and a lot of these standards that I've been talking about onto the mobile platform. Also, IE10, Internet Explorer has been doing great things and catching up to HTML5. Some other recent news, I already mentioned IndexDB, web workers, and WebSockets. They also will be bringing CSS3, 3D transformations, and also animations. So good to see that there as well. So let's wrap up. I really hope that you saw some tech that inspired you, and that if you have any problems or any concerns about where we're going in the future, that you will participate. The easiest way for you to do that is to come to the W3C Games group. This group doesn't perform any standardization work in itself. However, it's a meeting point for everyone with a common interest of making sure that the open web platform supports games as well as it can. And they understand the context and the other working groups where standards actually are being developed. So come there, communicate with people, let us know your needs, and we can get you into the right direction for communicating with the people developing specifications as we move the platform forward. And with that, I'll say thank you very much. There are notes from this presentation available at the link I have here. So all of the demos that I showed, the command line switches that I mentioned, they can all be found in the presentation notes. Thank you very much.